All right, moving on to Chapter 11, Section 4, we're looking at the graphs of these square root functions, so these radical functions that we have, and we're going to be looking specifically at square roots, not cube or fourth roots or anything. We're looking at specifically square roots here, and we're going to be looking at the graphs of them and what their general shape looks like, kind of their parent functions, and then what happens when we transfer them, and if we manipulate them in some way. So, let's get started. So here is what the parent function would be for these square roots. So you have y is equal to the square root of x, and as you see here, it's starting at 0, 0. That's going to be our starting point, or our starting point is what we're going to be calling it. And then you see it kind of does a kind of a curve and starts to flatten out as it moves up. But if you were to graph these and you plot in your points, 0, if you plug in a 0, you get 0. If you plug in a 1, you get 1. If you plug in a 2, you get a number less than 2. If you plug in a 4, you get 2. You plug in a 9, you get 3. Yada, yada, yada. Okay. So you see here you get 1, 4, and 9 if you plug in perfect squares. Okay. And you'll be able to graph it. So you could always use a table to be able to graph these. Okay, but this is your general one. So if everything's positive, it's going to go off into this first quadrant. Okay, so it starts in the middle, goes off in the first quadrant. Okay, heads off in that direction. Now, if it's y is equal to a negative square root of a positive x, then you see it's going down into the fourth quadrant. Okay, it's the bottom half of it. Okay, and it's the same basic curve. Okay, starts at 0, 0, curves out from there, but it goes there. Okay, now, what if the x is negative? So if it's the square root, y is equal to the square root of a negative x, okay, we end up with only the answer in the second quadrant. Okay, we don't have it anywhere else unless we transform it, or translate it, which we will be talking about it. Okay. And the reason why it's only over here is because if we plug in, let's say we plug in 4 into this equation, it'd be y is equal to the square root of negative times a negative 4. Two negatives make a positive, making this y is equal to the square root of 4, which is 2. If we plugged in 4, positive 4, with the square root of negative 4, which is an unreal number. It's an imaginary number. We don't graph it on a real plane. Okay, so because it's that negative x, we only allow the negative numbers. And the last thing we have is that if we have y is equal to a negative square root of a negative x. And if that's the case, we're down in the third quadrant. So you see with those two negatives, we wouldn't combine them because one's underneath the radical. We end up with our answer is way down there. Okay? All right. So those are the general shapes of all these radicals. Okay? So as you see, if it's just x squared, it's going from the middle to the upper right. The minus x squared goes to the lower right. The square root of a negative x goes to the upper left. Negative square root of a negative x goes to the bottom left. Okay, so that's kind of the direction they're heading. Now, next thing we have is our starting point. So with these radical functions, what ends up happening is that we're going to be adding or subtracting numbers with them. And so what's happening here is that we're going to have y is equal to the square root of x minus h plus k. As you notice, the k is on the outside of the radical, the h is on the inside. And when you are adding and subtracting numbers, what ends up happening is that you have a starting point. So you're not starting at 0, 0 anymore, you're being moved. And where is that being moved is your h and k. So in this case, we have y is equal to the square root of x minus 4 plus 2. That means that our starting point is going to be at 4, 2. So we start at 4, 2, and then we move in whatever the general shape is. In this case, since there's no negatives floating around in front of the square root or the x, that means that our answer is just going to be moving over 4 up 2. There's our starting point, and we go to the upper right. Okay. So the HK tells us where we're starting on these. Okay, so with this, what we have is that we have these transformations. So it's telling us, again, the starting point of our transformations. So if we have y is equal to the square root of x plus 2 minus 3, we end up having a transformation of a negative 2, negative 3. because you always take the opposite of whatever it is on the inside of the x. So if it's plus 2, it's going to be minus 2. So that means we're going to move to the left 2 because it's negative 2, and we're going to move down 3 because it's negative 3 for the y. So the x tells you left, right, y tells you up, down. Positives are right and up, negatives are left and down. Okay. So it tells us where we start, and then once we have our starting point, we just move in whatever the general shape is for it. For the most part, you're going to be either moving to the upper right or the lower right. You're not. A lot of the times you won't be going the other way, but just so you know. Okay, so take a second and describe each of these transformations. So I want to know left what, right what, up what, down what for each one. Okay, so for the first one, since we have x plus 4, that means that our point's going to be minus 4 because we take the opposite, and then it's a minus 7, so we take that as is. So our point would be, our starting point would be negative 4, negative 7, so the description of the transformation would be left 4 and down 7. So when you're asked to describe the transformation, you write out left, right, up, down, whatever it is. You don't write just the point, you say left, right, up, down. If I was asking for the starting point, you could tell me it's at negative 4 or negative 7. But the description of it is left, right, up, down. Okay, so now the second one, what's the starting, not the starting point, what is the transformation of the second one? The transformation of the second one, since the x it's minus 2, so that'd be positive 2, comma, negative 3. So positive 2, negative 3 means that we'd be moving it to the right 2, and we're moving it down 3. Okay, so right 2, down 3 ends up being our transformation for that one. Okay. All right, last thing here is that we have our radicals. Okay, if we have a number in front, how it changes the shape. So the blue graph on this one, the one in the middle, ends up being kind of our parent function. It's what usually is the growth of it. You can kind of think of that the standard one. If we add a number in front of it, so the 2 here, so you take square root of y, 2 square root x, you see that the curve ends up getting taller quicker. Okay, it grows faster. Okay, if we put a fraction under it, so a number less than 1, you see it ends up growing slower. It's more flat. You've kind of flattened that curve. Okay, so if the number is greater than 1 in front of the x, it's a steeper jump. If it's between 0 and 1, it's a flatter curve. Okay, for those. All right, that's the end of this section, and yep, that's section 4.